This is Dan Abbott. This is the third video I'm making on drawing efficiency for the AEDD 260 class at Southern Maine Community College. This one has to do with using polar tracking with relative angle set instead of absolute angle. What I'm going to do is take a look at what is it I'm drawing, and I'm going to choose an incremental angle for polar tracking. 15 looks like it will divide into most, if not all, of those angles, so that's my incremental angle that I'm going to use. I go to the polar tracking button on the status bar, open up tracking settings, set it for 15. Make sure it's set to track using all polar angle settings and not track orthogonally only, which is what the default is. Then down here, the default is normally absolute. Let's change it to relative to last segment. I'm going to draw with a polyline and start at 50, 30, because it tells me to do that right over here. And I'm sorry, right over here. And then all the lengths, the segment lengths, are given at the top. So I'll go directly to the right, which is 0, type in a 94 and an enter. Now I'm going to move my mouse so that it goes up to the supplement of 135 degrees. The supplement of 135 degrees is 45 degrees. In other words, this line segment is 45 degrees larger than the last line segment. B to C is 40, so I type in a 40. The next one gets smaller. Now, if I've got relative set, if I were to continue straight on the same angle as the last 2 points that I pick, it reads out an angle of 0. I need to make that smaller by 30 degrees, which is a supplement of 150. I go down 1, I go down 2, that's 30 degrees, which is going to read at 330 degrees because I'm going clockwise instead of counterclockwise. C to D will be 35. This next one, again, if I were to continue on, it would be 0. I want to go 60 degrees larger, so I just go up till it says 60. From D to E is 57. Next one is going to be 75 degrees larger. I just move my mouse until I get 75 degrees. From E to F is 82. Next one also got 75 degrees larger. Move the mouse till I get 75. From F to G is 61. Got larger again by 30 degrees this time. G to H, 38. Now once again I'm going back clockwise instead of counterclockwise, which is not the way the Cartesian system is normally set up. So I'm looking for an angle of 90, but it's going to read as an angle of 270. But you can see it's pretty obvious when you're at 90 if your incremental length, segment is 15 degrees. H to J is 85. Enter, and now it gets larger by the supplement of 60, which is 120. I move till I get to 120. From J to K is 53. Looks like that. And in this case, there's no dimension given, so we're just going to close it up. And that's the shape. To put that slot in there, I could use coordinate entry, or I could use temporary tracking. Let's go with circle. We'll do TT for temporary tracking. I'll track off of, I have to have my object snaps turned on. Let's go with endpoint, midpoint, center, intersection, and extension. I'm temporarily going to track off the endpoint. I go to the right and I go 21. That gives me a new tracking point. I go up above that tracking point, get rid of the first one, go straight up 35. The diameter of that, it's given as a radius, so the diameter is going to be 15. Copy the last thing that I created, just pick a point, move it to the right, and go 48. Now it's just a question of drawing a line. I can actually get that by tracking up off the center until I get an intersection here, go over to an intersection here, do the same thing, intersection, intersection, trim, trim, F for fence, so I can just drag a line straight through it. Now I've got the whole thing drawn. So that's how using relative angles is helpful when you're drawing. However, we'll get another situation here. This one was clearly set up so that you would draw counterclockwise, which is the Cartesian default. Take a look at this one right here, and it's not set up the same way at all. Just erase this. In this case, we're going to have an incremental angle of 15. Looks like it's going to work for everything except right there. So let's go with an incremental angle of 5. So we'll go back over to AutoCAD. We'll go down to the polar tracking settings. I'm going to go and track 5 degrees. It's going to be a relatively small incremental angle, but it's big enough so we can use it. Track using all polar angle settings, still relative to last segment, but because we're going to end up going clockwise instead of counterclockwise, the relative to last segment is going to be a little confusing unless I change my units so that in this drawing I'm not measuring counterclockwise, I'm going clockwise instead. AutoCAD's default, because that's the default for the Cartesian coordinate system, is to go counterclockwise. I'm changing that, but don't forget to change it back. Now we go to a polyline. It says start at 190, comma 30. So I'll do that. First line is going to be 0, or 180 in this case. That's going to come out 94. Now this next angle is going to be 45 degrees larger than the last one. So I just move my mouse till I get 45 degrees, type in a 40. The next one is going to be smaller by 30 degrees. If I were to continue on straight, it would be 0. I need to go down 30 degrees, and because now I'm changing the angle in a counterclockwise way, it's going to read out as the difference between the angle I want and 360 degrees. I'm going to move this down until it gets to 330, which is right there. At 330, I'm going to type 35. From here, I'm going to go up, and in this case, the angle is going to be 60 degrees, just as it's given, 57. Next one is going to be an angle of 75. I go until it reaches 75, and that's because the supplement of 105 is 75. When I add 75 and 105, I get 180. 82. Now, if I were to continue on straight, I get an angle of 0. It's going to increase by 75 degrees. I just go down until I get to 75, which is right. You'll notice, by the way, every once in a while it shows endpoint instead of relative polar. That's because I hovered over the endpoint, which I didn't need to do. And I need to go back and deselect it. If you hover, it'll select an endpoint. If you hover over the thing you selected, it'll clear it. So now I'm coming down where I've got 75 degrees. Oh, it's not 75, my mistake, 45 degrees. So I'm going to go down to 45 degrees, which is right here. That's a supplement of 135. 61. Next one got bigger by 30 degrees, goes down like that, that's 73. Next one got bigger by 20 degrees. And again, it is easy when you've got a lot of running object snaps set to be acquiring points accidentally. So this one's going to be 20 degrees. We're going to go down like that. That's 43. Close the whole thing, and then we have that shape right there. Quickly, we'll do a circle, and the circle will be from this endpoint right here. I'm going to go at negative 31, comma positive 54. Negative because we're going to the left, 54. Positive because we're going straight up. Diameter of that hole is 15. We'll do an array. In this case, it'll be I'm using the array command here at the command line, so it's a negative array. Last item that I selected, a rectangular array. We need 2 rows, and we need 1, 2, 3, 4, 5 columns. The distance between rows, that's the up and down, that's going to be 30. The distance between columns, however, is going to be a negative value because it's going to the left instead of the right. That negative value is going to be 27. So negative 27, enter, and now we've got all the whole. And one more of this type, and the one more of this type is going to be drawing the property for this very simplified property map. On this one, I'm going to start a brand new drawing. When I start the brand new drawing, I'm going to use the AutoCAD DWT instead of AutoCAD ISO. I just said always load because it's loading my AutoCAD LSP file. Now if you take a look at this property, and this is a survey map, property is measured in decimal feet, and the angles are given in surveyor's units. So before we start doing anything else, I'm going to go into units. I'll leave precision set the way it is, And for angle type, instead of degrees, I'm going to go to surveyor's units, and the precision is going to be degrees, minutes, and seconds, which is right here. Pick OK. Done. Now just a point about how surveyor's units work. If we take a look at going from A to B, the angle from A to B in absolute terms is north 24 degrees 58 minutes 15 seconds west, which just means starting from due north, that property line is going to rotate at an angle of almost 25 degrees. And it's given in surveyor's units in the United States in degrees, minutes, and seconds. Now we can type that in at the AutoCAD command line using coordinate entry, but the only thing we can't type in, because there is no symbol for degrees on the keyboard, is the degree symbol. Everything else is something on the keyboard, a letter, a number, an apostrophe, and a quotation mark. So the degree symbol doesn't appear in the keyboard, so we'll pick a letter. Autodesk picked a letter, and that letter is not surprisingly the letter D. So I'll go over to the drawing. I'm going to do a P line starting at 50, 10. We're going to draw in decimal feet, by the way. Move this over here a little bit. And now I have to type in the coordinates here. Polar tracking isn't helpful to me when I've got angles that have such small increments. So at 90.54, no foot mark because we're simply using decimal units as opposed to architectural units. Then the angle will be entered as north 24D, as in 24 degrees, 58 minutes, so that's just the apostrophe, 15 seconds west. Press enter, zoom back out a little bit. Oh yeah, let me just get rid of that line segment right there and start this over. What I did not do was set my limits large enough for what I'm about to draw before I got started. That's always a good idea, so I'm going to do that right now. If I take a look at this, it looks to me like if we go with limits, say, of 100, I'm going to do it, do a little bit more. Let's say 200 by 100. That's 200 by 100 feet. Then do a zoom all. Now this is going to work out a little better. So P line starting at 50, 10, at 90.54 at an angle of north 24 degrees, the D instead of the degree symbol, 58 minutes, 15 seconds west. We get that first line at 80.33 at an angle of north 45 degrees. Now it's 0 minutes, 0 seconds, which you can type in there, but you can also just type in the letter E and you'll get the same thing. At 108.83 at an angle of 44 degrees. And like I said, we can put the 0 minutes, 0 seconds east if you want. Then you'll get the right line, except I mistyped something. Let's go back and do it again. From here, use the at symbol as our starting point. 108.83 at an angle of south 44 degrees east. Enter. Looks like that. At 72.25 at an angle of south 33 degrees west. Looks like this. At 54.83 at an angle of north 4.83 at an angle of north 90 degrees west. Now because this is a survey, there's going to be a gap from the beginning and the end, and so here's where you're going to have to zoom in and take a look at that gap. In this case, that gap is not very large. So right there, and it's not normally very large. So when it asks you over here for the gap, the size of the gap at A, I'm asking for that size right there. And the size I'm looking for is the distance directly from that point to that point. So what is the length of that line right there is what I want. I would just use the dist command. If you do use the dist command on this one, note that the direct distance is 0.0014, even though the delta y, in other words, the difference in the y-axis is 0.0012 and the distance in the x-axis is 0.0007, the actual distance of the size of that gap is going to be given as 14. Well, 1,000, well, 0.0014. I'm starting to talk like a machinist there for a minute. That's it for this one.